Because we were discussing about the multi-threading, right? So we have to continue with that, right?
Yeah.
Yeah, 1 second. Just give me a minute. Let me.
Last time you also told that you will give some programs so that I can because
Today,
most
by
of the
the end of the
because
day, I will just give you, okay?
yeah because most of the topics of core Java are covered actually. Some only
Yeah,
few are remaining. So you told that you will give some programs so that I can prepare myself for those programs.
yeah, I will give you today. Sorry. One second. I'm just. Let me share my screen. I think it opened my console. Okay, so I hope you can see here, right?
Yeah.
Okay. New package. Stay 20, I think, right? Yeah. All right. So today let's talk about the multi-threading again, okay? Because last class when we discussed, it was not proper for you, right? So what we do, let's again do the multi-threading. Okay. So multi-threading. What does mean by multi-threading? What that comes to your mind? What exactly?
Multi
Yeah.
in multi-threading, mostly multiple threads are running for the processes and simultaneously. And if I mean they are based on the priority like FIFO, LIFO, like that. So
Okay. Any other?
yeah,
Okay. All right. So now coming over here with a multi-threading. So as you said, yes. So it is a programming concept where multiple threads that run concurrently within a process.
Hmm.
Okay. So uh, it's a programming concept where multiple threads that run concurrently, okay, within a process. So to perform a task, okay, to perform a task, they will run concurrently. So now coming over here, if you take that in Java, okay, if you take that in Java, basically multi-threading means it's a programming concept where the multiple threads that will run concurrently within a process to, within a process to perform a task. Okay. Now the
Hmm.
same thing if you take in Java, it allows the program to execute multiple parts of a process. Okay, so in the Java, multi-threading that allows a program to execute multiple parts of a process simultaneously, as you said. Okay, simultaneously to improve the performance. To improve the performance, and also we can say like a resource utilization. Okay, so it will be utilized. This is the general, the definition we can say. Okay, so in Java, it allows a program. Okay, it allows a program to execute multiple parts of a process. Okay.
Yeah.
All right. Now, why do we want to use the multi-threading?
See,
Why do we need it?
we need
Yeah.
it because see, let's take example of any application or server, application server or anything. So in that we have multiple processes. So all process need to be run simultaneously so that our application will run smoothly. So so this is the reason why we use the multi-threading concept.
Okay. Perfect. So why we use is for your better CPU utilization, right?
Yeah.
Because threads, they share the same memory.
CPU
They share the same
utilization,
resources.
memory utilization. Oh, there are multiple things are there. So there are a lot of process in every application also. So all are called threads.
Okay.
So it's like,
Now let's understand this multi-threading in a simple way also.
yeah,
Like imagine you are in a restaurant kitchen.
yeah,
Okay. A single chef, that is a single thread, okay, us doing everything. Okay, so in a home that all our moms will be their single thread, right? So they will be doing by themselves, like chopping the vegetables, cooking, serving, and washing the dishes, right? Everything will be done by them, right?
yes,
So it takes a long time because the chef can only do one task at a time,
yeah,
right? So that is what. So now, same thing if you see, if there are multiple chefs, one can chop, one can cook, one can serve, one can wash dishes. And this task are divided and the food is prepared and served much faster. And this is exactly how multi-threading works in computers. It allows the multiple tasks to run simultaneously instead of one after the other. Okay? Instead of one after the other, it will run simultaneously. Now, why we use, yes, as you said, for the better CPU utilization, okay, better CPU utilization because the threads will share the same memory and the resources, but at the same time, it will execute independently. Even though if they share the same resources, they will execute independently. So that leads to the efficient CPU usage. And the second part is faster execution. Faster execution. Just give me a second. Faster execution, which means when the multiple tasks can be performed simultaneously, it reduces the overall execution time, right? So even the scenario we saw, right? When you have multiple chefs, they will share their work, so the food will be served so faster, right? So that is your faster execution. And the third one we can say like a responsive applications. So especially this multi-threading is useful in the GUI applications where UI remains responsive while the other tasks run in the background. Now, if you say your WhatsApp, okay, whenever you open the WhatsApp, it is not that you are getting a message. The WhatsApp will be running at the background, right? Whenever
mm,
the message comes, it will alert you, right?
mm,
So responsive applications, and then we can say like when the threads are executing, so let's say like asynchronous processing. So when the threads, okay, threads allows the task to be executed without blocking the other operations. It won't block. So let's say like WhatsApp message is coming. At the same time, if you're receiving a phone call, your WhatsApp message will not block the phone call. Or at the same time, the phone call will not block your WhatsApp message. They both will be coming, right? So the threads that allows the task which is to be executed, that will not block the other operations. Okay, that will not block the other executions. Okay, this is clear. Now,
Yeah.
where do we use this? Where do we use this? So with I mean, in our real life also, we will use this multi-threading in many cases. So your mobile apps, okay, your
Yeah, yeah.
mobile apps and
WhatsApp,
websites.
WhatsApp is an example of multi-threading itself. WhatsApp application. In
Yes.
this, we have we have the process, multiple process. We have some process is waiting, some in pause state, some is running. So it's like,
Yeah. Another also we can say like suppose for example, let's say like uh, you're using Instagram, let's say.
yeah,
So in the Instagram, let's say you're watching some video, okay, or you're sending a message. But at the same time, you can download something at your back end, right? At the
yeah,
background,
yeah,
right? So that we can say. Then video games. So one thread that handles the player movement, and another thread that will handle the graphics, another thread that will handle the background music, right? Video games we can say, and then ATMs. Another thing, ATMs. So multiple people will withdraw the money at the same time because different processes run in parallel, right? And then you can say online shopping. How does online shopping helps?
yeah. At the same time, we are. I mean, the we have added some item to the cart also, and that is then after that we are doing the payment. So that is the item is still in the pause state, or we can say in waiting state. So it's a example of multi-threading.
Yes. So when you're browsing the items, right?
Yeah,
You liked one item, so you will be added to the cart.
yeah,
So there comes the another thread which handles the cart. Your product is stored over there and it is handling, right?
yeah, yeah,
So that is online shopping. And even the next one, we can say our web browsing.
yeah,
You will be processing with each tabs, right? Each tab that runs as a separate thread. So even if one crashes, the other keeps working, right? So now even see if you have this is also a multi-threading, right?
yeah,
So I have tabs over here. Each tab shares the same resources, but each file that acts independently, right?
yeah,
So this also we can call it as a multi-threading.
yeah,
Okay.
yeah,
Now let's go with the threading part. Okay, thread. So we talked about the multi-threading. So now let's talk about the thread in Java. Okay, thread in Java. So now
yeah.
coming over here, the thread, okay, it's a lightweight subprocess.
Yeah, it's an
Okay,
independent process, which is lightweight process. Yeah.
exactly. So it is the smallest unit of execution. Okay, so thread in Java, if you see, it's a very lightweight process and it's the smallest unit of execution, like chopping the veggies, serve
Mm.
the dishes, wash the vessels, right? So each and everything will be a smallest unit. So now this Java that supports a built-in, okay, let's say like Java supports a built-in, let's say like this. Java provides a built-in support for the multi-threading. Okay, for the multi-threading through the thread class. So we have a thread class, inbuilt class we have, okay. So with the help of the thread class, this Java supports the multi-threading, and we have a class and also we have an interface. Okay, to support this multi-threading, we have a class and also the interface. So that interface is runnable. Okay, so in order to support this multi-threading, Java has a built-in one. So your thread class and the runnable interface. Okay, if you want to support the multi-threading, yes, you have two options. Either you can go with the class or either you can go with the interface. Okay, but you can choose anything. Thread class, runnable interface, everything. Now, let's say the life cycle of a thread. What might be the life cycle of thread? If you say a thread, okay, that has to undergo the steps. Okay, undergoes the, let's say like following states, let's say. So the first one is new. New means created stage, we can say. Okay, created stage, which means the thread, okay, let's say like the thread is created but not started yet. There is a chef in the restaurant, but they didn't start their work yet. Then you have runnable. So now the thread is ready to run, but waiting for the CPU allocation. So now the chef is ready to work, but he is waiting for the kitchen to be ready and the veggies to be ready to cut, chop everything. Then let's say like running. Running means the thread is executing, we can say, which means the chef is in the process of chopping the veggies, serving the dishes and all those things. Then the another one is blocked or waiting. Blocked or waiting. So thread is waiting due to the resources unavailability. Okay, if the resource is not there, for example, let's say like, okay, your phone got switched off in the mid of the downloading. So what will happen? Or let's say downloading is happening. Unfortunately, the network got interrupted. So what will happen? Your
The process will be in the wait state.
Yes, because the network is not available. So your thread is waiting due to the resource unavailability.
Yeah.
Okay. All
Yeah.
right. Or let's say like your WhatsApp also, let's say, suppose if it is not synchronized, okay. So if it is not synchronized, it will be waiting for the messages, right? It will be
Hmm.
waiting for the synchronization.
Yeah.
Then fifth one, we can say like a terminated. Terminated. So which means like thread completes its execution. Okay, completes its execution, or we can say like it's forcefully stopped. Either it completely executes or we can stop it by clicking on the stop button. Okay, that is what it is. So these are the life cycles of the thread. New, runnable, running, and then we can say like a blocked, awaiting, and terminated. Okay, so you, as I said, you can create the threads. Okay, you can create the threads either with the help of the thread class or runnable interface, right? Runnable interface. So now let's talk more about this today. Okay. All right. So now coming over here, let's go ahead and create the threads in Java. Okay. We are going to create the threads in Java. So in many languages, yes, we can, but now let's learn about this. So let me say the thread tester over here. Okay, and then next on links. And one more thing, like try some basic Java questions in the hacker rank. And I forgot to tell you. So at the end of the session, please remind me so that I'll show you. In the HackerRank, you have an option for the basic Java, I think. I'll check it out. So if there is there, you can try to attend those questions so that you can get a certificate also.
Yeah, you can let me know that web page, or you can share me the link. I
Yeah.
will check.
Okay, so it's like a basic Java is also there. I mean, for every language, it has a basic also and advanced level also. So though, if you go with the basic, the concepts, whatever we have learned so far is sufficient. You can utilize that. So there will be 2 questions. Okay, at least if you try to answer one question also, you will get a certificate.
Okay.
Okay, that certificate you can upload in the LinkedIn also. Okay, you can add it in your resume as well. Okay, all right. Now, coming over here, thread. So we got to know, I'll just close the other one. I don't want to disturb this. Yeah. So we got to know that the thread, the multi-threading that can be implemented by using either thread class or by using the runnable interface, right? So let's see both also. Okay, let's see both also, how we can use the thread class and how we can use the runnable interface. So now let's say this thread tester, okay, by using the thread class, let's say. Okay, so now what here I'm going to do is already thread class is there. Okay, already thread class is there. So what we are going to do is we are going to extend that. Okay, so now let's say my thread tester is there. Okay, I'm going to take this as a child for my thread class. Clear?
Hmm.
Okay, already we have a built-in class that is thread. So whatever I'm going to do, if I want to create a multi-threading, I want to make that as a child for my existing thread class. Now, if I want to make a child, what concept I can use? If I want to bring a parent-child relationship, what concept I can use? Are you there?
Yes, yes, tell me.
Huh. So if you want to bring a parent-child relationship, in that case, what concept we will be using?
Inheritance.
Perfect. Yes, inheritance. Okay. So we will be using the inheritance. So now coming over here, what I'm going to say, we have created a class, right? So I'm going to make this class as a child for my existing thread class. So for that, I'm going to make use of extends. So the class what I created will be the child for my thread. Okay. Now I'm going to create the object. Okay. I'm going to create object. So if you want, you can just click on this. See, you can see here. So this is the class thread class. Okay. So you can see the class thread which implements the runnable. So runnable interface. I said you right. So either you can go ahead with the thread class or you can go ahead with the runnable interface. When you are using interface, you will be using this implements keyword. Okay, now if you scroll down, you can see these are the variables that has been used. Okay, and then yeah, if you scroll, you can still you can see the variables blocked on, and then yield. So sleep, you can see we used to say in a thread dot sleep, right? So sleep, and then see what are the methods that your thread class has. You can check it over here. Okay, you can check it over here. But these are the library kind of stuffs. So to understand that, it will take some time, but you don't want to get complicated by go through it. Okay, so if you want to make sure that what are the methods that the thread class has, okay, you know that once you create an object with the help of a dot, you can get to know what are the objects that the thread, I mean, what are the methods that the thread class has, right? So now let me say I'm going to create an object. Okay, let me say thread. Okay, let me say like a thread tester. Like, okay, I'm just going to say thread one, or let me say short as a T1 equal to new thread tester. Okay, so we have thread tester T1 equal to new thread tester. Now, if I wanted to make sure that what are the methods that I have with the thread class, I can say T1 dot. So T1 dot. So automatically it gives me what are the methods that I have, right? So what are the methods that are applicable with a thread? So you can see over here, thread, right? Start, stop, suspend, toString, wait, and then max priority, min priority. So you can see here the thread, right? So which means like these are the things that are available in the thread class. Okay, these are the methods that are available in the thread class. You can make use of it. Okay, now we want to start a thread. So that is what the life cycle that we have. So once you create, you have to start it. So now let's say T1 dot start. I have start. So what it says, this thread, this method caused the thread to begin the execution. So your Java virtual machine calls the run method of this thread. So when you say start, it will call the runs method. So which means like you want to create a run method in order to start it, right? So you can see. So the result is that two threads are running concurrently. The current thread which returns from the call to start method and the other thread which executes its run method. So two threads will be there. One is to start, okay, and then uh, you will be running. Another one is run method. So suppose if this run method is returning something, that will be waiting for it. Okay. So now coming over here, let's say start. So what it says, if the thread starts, what it will do, it will execute the run method. But as of now, we don't have a run method over here, right? So now let me go ahead and let me say public void run method. So start, when you say start, it will go through the run only. So for example, if I say run one, if I say, it won't consider. Okay, it won't consider. Let me say over here. Okay, so I want to get thread is running, right? So let me say over here, if I execute it, wait, this is of Java runnable tester, not this one. I want to run this. So let me say run as Java application. You can see this is the thread tester of our class, right? Our class is thread tester. You can see terminated. But what we said, we have given the print statement thread is running. So, which means your method name is varied. So when you say thread start, it will first look for the run method only. Okay, it will just look for the run method. So now if you give it as a run and if you run this, you can see thread is running. Okay, so what we did over here, we extended the thread class and we override the run method which contains the task to be executed. Okay, so suppose if you are not providing this, what will happen? Your thread class has a run method. Okay, your thread class has a run method. So we are overwriting over here with the message that is thread is running. And then what we did, we call the start to begin the execution. Okay, so this is by extending your thread class. Is it as clear?
Yeah.
Now the same thing I'm going to do with the runnable interface. Okay, runnable interface. Let me say runnable tester. Runnable tester. So I want to make use of the runnable, but runnable is the interface over here. So if I want to bring a relationship between the class and the interface, I will be using the keyword called implements. Now, as soon as you say implements, can you see the runnable tester is having the error? What was the error might be?
You can click on this and you can check.
Okay. But before that, any guess? Okay. One point, which is means when you're using an interface, the interface will have some method body. Okay. Your interface will have some method body. So when you're implementing the interface, you have to make sure that all the methods are implemented in your class. So if you see add unimplemented methods, okay, when you can see over here add unimplemented methods, which means your interface is having some method body that you have to implement in your class. That is what that you have to implement in your class, okay, so that you can go ahead and add the values whatever you want. So now I say add unimplemented methods. Can you see it implemented the run? Got it? It implemented the run again. So the same step 1B. So you're going to create a method object over here. Let me say like rt1 equal to new. So here this runnable is interface. Okay. So now let's say like this runnable is interface and we are implementing it over here. So now if I want to create an object for this, I can pass this through the thread class. If I want to create an object for this, okay, let's say like if I go ahead and if I say this for RT1, okay, do you have a start over here? Do you have a start method over here? Do you have?
Can you go down a little bit in this?
Yeah. No,
It's not there.
it's not there. So how you can? So you are creating an object for your runnable tester, right? And that object wants to pass as a parameter to your thread class. The object what you are creating for your runnable, okay, that has to be passed as a parameter to the constructor of thread. That is your thread class, and take an object of a thread and then say new thread. Now in this, okay, now in this object creation, this will be the constructor as well, right? So when you create an object, it will invoke the constructor, right? So you're going to pass the runnable tester, the runnable one, as over here. So you are passing the runnable, you are passing the class which implements the runnable, that object, okay, that object to the thread object. Okay, now if you go ahead and see T1 dot, you can see all the methods that you have. See, is alive, is statement, join, notify, run, set, even your start as well. Now if you say start, this will start your thread. So now the same thing, if I say over here, so thread is running, but let's say like it is runnable thread. Okay, so here I'm saying thread is running, but it is a runnable thread. Okay, now if you run it, you will get a thread tester. Let me say run as application. So can you see the console? Thread is running, but it is a runnable thread. Right? So when you're using the interface, you have to pass the object of that particular class to the thread class. Okay, so here what we are doing, we are implementing the runnable interface and we are overriding the run method and we are creating a thread object and we are passing the runnable instance. And then we are saying start to execute. Now, which approach we have to do? We have runnable interface and the thread class. So which one we have to choose? Okay, so which one to choose? So first one, you have extending thread. Another one, you have implementing a runnable. So extending is class, implementing is interface. So when you have to choose, let's talk about the pros and cons, the positive and the negative. So when extending the thread, what is the pros? It is very simple to implement, right? It is very simple to implement. So in the runnable, when we created an object and when we tried to run a method, we got stuck over there, right?
Hmm.
And it brings a complicate over here. So you have to first create an object for the runnable, and then you have to pass that object to the thread class. So it is like extending. But now coming here to your thread class, it's just one object with the class what we extended, right? We are not
Hmm.
passing the particular object to any other methods as any other class as well. So implementation is easy over here. Okay. And coming over here to the next, if you say the cons, this cannot extend another class. If I extend the thread class, yes, I can extend only one class. Suppose if I have another class, let's say class A, I have class A. So this class thread tester that cannot extend the class A. You cannot say like A, which will comes like a multiple inheritance, but that concept is not applicable in Java, right? Yes. Am I right? Are you there? Am I audible? Am I am I audible? Hello? Am I audible?
Yes, ma'am, you are audible.
Okay. Can I check with Pavan because I'm not getting any response?
Nidha ma'am, let me connect with Parshad. Please be online.
Sure, sure. You can pass the recording meanwhile.
Can you hear me?
Yes, yes, I can hear you.
Yeah.
Okay, let's continue. So we were discussing about this, right?
Yeah.
So now the drawback of using the thread class. So when you say extends thread, you cannot extend another class, which means I have a class A over here. If I want to extend this class A also, I cannot say like A. I mean, I cannot say extend thread comma A. Because when you are extending two classes, then that comes with the multiple inheritance. Java that does not support multiple inheritance, right?
Yeah.
So here, if you feel to extend any other class, so that is not possible. That is the one drawback that we have. Now coming to the runnable, okay, if you go with the runnable, so the positive point is like implements, yes, it supports the multiple inheritance. So if I say class A over here, I can simply go ahead and I can say comma A. Okay, I can simply go ahead and say comma A. Now coming over here, if you see the multiple classes, if you want to make use of it, you can make use of it over here. Now at the same time, coming over here, okay, so if you're going for the large complex project, so your implementation is better. Runnable, using the runnable is better. So better for large complex projects. And the negative part, the cons part is like you need a thread object, right? So you need to create a thread object as well. So requires to create a thread object. Okay. All right. So which one to choose? You can, based on this, you can choose which one you wanted to go. So now we have thread methods. Like when you say this T1 dot, you have the methods like this, right? So let's talk about the few methods now. Okay. So now let's say like thread methods. So the first one, let me say start. That is what we do, right? That is what we do initially. Start. Start. So what does it the start will do? It will start a new thread. So which means you can give more than one object for this. Can we create a more than one object? So when you say like this, all the four will be running at the same time, right? At the same time, all the things will be running it up, right?
Yeah.
Now, coming over here with the next, you have the run method. So run method, what it will do? It will define the task of your thread. So task of a thread. So what it wants to run. So that defines it. Then we always use sleep, and then we will use some numbers in numbers, and that numbers represents in the milliseconds. Okay, so we always use sleep sometime. Okay, so what the sleep will do? So this will puts the thread to sleep for some milliseconds, which we mentioned in the MS place. That is milliseconds. If I say thread.sleep of 5, so it will wait for 5 minutes. So let's say like there is a dependency. Okay, when you're when you're creating an application, let's say web application. So due to the network, due to the network dependency, the login process, username and password, it will take some time to load. Okay, so if you feel that, then you have to wait for your next step to execute, because compiler will keep on executing line by line. It doesn't wait for any response. Okay, but if you feel like you want to get a response, based on the response, if you want to act, you can put a halt over there. How you can put a halt? Sleep. Okay, sleep method you can use. Okay, then we have join method. So join means it waits for a thread to finish the execution. And then alive is alive. So as the name itself says, right? So we will be checking whether if a thread is still running. And then you can set the priority. Initially you said, right, so priority. So yes.
Suspend also there, na? Suspend yield method is there.
Yeah. So let's go one by one. So let's say like it sets the thread
Interrupt to destroy,
priority.
stop.
Yeah, Lord. Yeah. So it sets the priority to 1 to 10. And if you want to get the priority, so you have the get priority. I'm sorry. So it will get the thread priority. And then you have interrupt. Okay, you have interrupt. So interrupt a sleeping or waiting thread. Similarly, you said the yield and all those things, right? So if you said go over here, so if you wanted to look into like any of the method, just you can go over here, name. So it will return the thread name, get priority. It will return the thread's priority, get state. It return the state of the thread. Okay, it return the thread state and interrupt. So interrupts the thread, right? So currently, I mean, it's like the current thread is, interrupting itself. Okay, and then join, wait for the thread to die, is alive, is daemon. Okay, and then is interrupted, whether your thread is interrupted or what. Then you have notify. See, it wakes up the single thread that is waiting. Okay, that is waiting. And then you have suspend. Okay, so but this suspend is deprecated. So whenever the method is deprecated, we have to avoid using it. Okay, we have to avoid using it. Then you have the, I mean, you said it yield. Yeah, you have this yield. So a hint to the scheduler that the current thread is willing to yield. Okay, so like this, what are the things that you want? You can. So yield, if you see. So imagine that you are in a queue at the movie, I mean, at the theater counter, let's say. Okay, so you have a small, I mean, you have to purchase tickets, or let me say, like you are at the grocery store, let's say, the supermarket, let's say. So imagine you are in a queue at the supermarket. You have a small number of items, but the person behind you has only one item, right? Okay, so out of kindness, yes, you can let them go ahead. You have only one item, yeah, you can go ahead and you do the billing. If the, I mean, out of the kindness, right? So this way the queue moves more efficiently. That is what the yield. So here the yield method works similarly. So it allows a running thread to give up its turn and lets another waiting thread to take over. So when you have more jobs to execute, the another thread is having one job to execute, as you can say yield, so that one job will execute and it will go off. Okay, that is what it allows the running thread to give up its turn and lets another waiting thread take over. But however, it does not guarantee that the next thread will immediately start. Okay, but it's just a suggestion to the CPU. That's it. Okay.
Okay.
Now, if you want to
Then
make use of,
what is the difference between set priority and in this yield method? Both are same.
okay, set priority and yield method. So now what we will do in the set priority. So the set priority, if you see, we will be using the priority that is from 1 to 10. That is what we have seen over here, right?
Yeah,
You can set the
but
priority with a 1 to 10.
I
Now,
think indirectly in yield method also we are doing the same. Now we are setting priority. We are giving the priority kindness to other to
see,
go
now
ahead.
when coming over here with a set
Like
priority, I can I can have that trust that my all my threads will work. But when I go with the yield, I cannot give the guarantee over there my next thread will start immediately. So yield means we are suggesting the thread scheduler to pass and allow the another thread to execute. And it does not guarantee the switching. It only hints. So no guarantee that another thread will immediately execute.
might be he's not interested or don't want to execute that time. Even we are giving the kindness or we are giving the priority. See,
Exactly.
in the set priority, it's definite. If we are setting the priority, then the
It
execution
will
will
definitely
happen.
execute, right?
Yeah.
So based on the priority, what you said, it will go ahead and execute, right?
Okay.
So the yield does not guarantee that another thread will run immediately.
Okay.
Okay. But in the set priority, it is not like that. When you want some threads to have more importance than others, then you can use set priority because it will run. But when you can use yield, when you want to let other threads run, it's just a suggestion, okay? But it's just a suggestion. But your yield method does not guarantee the execution.
Hmm.
And at the same time, it won't guarantee the execution order as well. Your thread scheduler will always decide.
Hmm.
Okay. Now, if you want, we can see some example for the set priority, and then we can go ahead with the yield also if you want. Let me show
Yeah.
that. Okay. So let me see new. You can see like set priority tester. So now what we are going to do, like set priority. We are going to set the priority. Okay. So again, I want the same class only. So what I do is I will take this. Okay.
But
I will.
in the last also, why we are repeating the process? We are not using like T1 dot start. One time we use, then in the second we should use pause or some get priority set different. It's
This site simply to show as a demo. I said you can create
yeah.
multiple objects. That to discuss the pros and cons, I said this. Okay. So we
So
just created the object. Now only we are going to do into the other methods and all. Okay. Now I'll make use of the same coming over here. So here I'll take only two objects.
take the multiple, but I want that can we use the different methods or different
So now
this
let's you
reads?
wanted the difference between the set priority and the yield, right? So I thought of showing you them.
Okay,
Then we
okay.
will go ahead. Okay.
Yeah.
Now, okay. So now coming over here, if you see, all right. So let me say the thread is running, and at the same, or I will give a different one. Wait. Let me say thread dot current thread. So it will give me the current thread dot get name. So it will get the name of my current thread, and I will say that is running. Second, 1 second. Okay, so let's say this particular one. System is running. Then now we say here, I will bring this start at the end. Now I'm going to set the priority. Okay. Now let's say set priority. It is going to be the number. The number will be like 1 to 10. So now let me say like we have a maximum priority and the minimum priority. See, max priority, minimum priority, and the norm priority. Normal priority means let's say like 5. Okay, normal priority is 5. So now let's say like max priority. Then let's say T2 dot set priority. And I will say like thread dot min priority. So T2 is having the minimum priority. T1 is having the maximum priority. Or if you want, you can make like this also. T2 is having the maximum. T1 is having the minimum priority. Okay. Which means maximum priority means it is 10. Minimum priority means it's 1. Norm priority means normal priority means 5. So we have like this. Okay. So now let's execute this. Okay, so priority threshold. Okay. The thread is running. Okay. So you can see I'm just getting the thread is running. Thread dot current get name. It is getting the thread and that is running. Now coming over here, if I use the yield method. So if I go over here, if you want, I will use the another one.
Why it is not taking get name? Why it is not taking?
1 second. Just I'll just copy this. Not going to set the priority here. Okay, not going to set a priority. Then let's say over here, thread dot yield. See the difference, and then let's talk about that. Thread is running. So both the things I'm getting. So both the threads in here coming over here, both the threads may switch the execution frequently, but it is not guaranteed as well. Okay. Now coming over here, so here we have created two threads, that is T1 and T2. Okay. And coming over here in the priority also, we have created T1 and T2. So now over here,
One
we have
second.
set
Why it is not printing the name dot get name of the three T1 thread is running, or like three T1 is running, three T2 is running?
because I didn't use any extents or I didn't use any runnable. Right? If I want to use the threads, I want to extend it, right? Let me say extends thread, that one is there. And for the yield also, I will say extends thread. So there is few issues on my code. Okay. So extends thread. Okay. So what we are doing over here, we are creating a class. I forget to extend it. Okay. And then the run method belongs to the thread class. Okay. So now coming over here, we have set the priority, and the priority that does not guarantee with the execution order. Okay. The set priority that suggests the priority to the thread scheduler.
Can you
But
print now?
the thread dot current thread dot get name.
Then what is the use of dot get using dot get name here?
Which one?
See,
Okay.
in the
Now wait.
print you are printing three dot current three dot get name. Then what is the use of this dot get name method?
1 second. Extends. It has to come like 0, 1. So in
Can
our
you
previous class we did, right?
can you just remove this dot get name? Let's see what will happen.
So which one you want me to remove?
Dot get name in the print method. Yeah. Hmm.
Let me see. Run. But if I say runnable, I have to use the thread class.
Hello? Hello?
Yeah, can you hear me?
Yeah, I can hear you.
Okay. So in our previous class, yes. So here we did the loop, right? So we did the loop and then we get the same threaded name and then we gave the count over here. So when you run this, you got an you got like this thread 0 like that. Okay. So for everything we gave we gave the same thing. But if you want to see that, we used the for loop. So similarly, if you want, we can use that over here also. Okay. The output will be varied. If you want, 1 second, I will just go with this. 1 second. If we run this, we are getting thread is running, thread is running. Okay. So we can provide the custom name also. Okay. If you want, you can provide the custom name. How you can provide the custom name? Let's check whether set name is there or not. You have the set name, right? If you want, we can set that. Set name, let me say job 1. P2.set name. Job 2. Okay, now let's say why it is not getting it. 1 second. Security test. Why it run? Get name, it has to get the name, this particular one. One second. After setting the name also, it is not executing. Just give me a second. T1 dot get name. See, it is getting the job 1.
Hello.
Yeah. So here the name is getting fetch, but here the name is not getting fetch. So thread.current get name, and we are making sure it is running in the run method only. When you say start, it will be going with the run method. Okay, wait. Oh my God. I'm really very sorry. I'm really very sorry. I make a mistake. I made a mistake. Object creation is wrong. Object, I just copy pasted over here, right? I forget to change the class name. It is pointing to the thread tester class, and that's the reason it is keep on coming. Thread is running. I'm sorry. It's my bad. I'm really very sorry. Even for the yield tester also, I did the same. Oh my God. I'm sorry. All right. So yes, in that case, it will definitely work. Okay. So that's the reason I always go with the writing part. I won't go with the copy paste. Okay. Let me do that. I'm really very sorry. Set thread. Yeah. Now, if you go ahead and run, you can see thread 0, right? So now you can see the thread 0 is running, and then the thread 1 is running. You got it now? I made a mistake. It's a major mistake. So we are creating an object for the another class in this particular class. So that's the reason it was going with that particular method, that is thread is running. So we have to create an object for this particular class that I failed to do it. So that is the reason. So you can see thread 0 is running, thread 1 is running. Now we yield tester also. I want to create the class. Now let's see that. Yield tester. You can see thread 0 is running, thread 1 is running. Now coming to the priority, we have, even though we set the maximum priority and minimum priority, it does not guarantee also. Okay, it does not guarantee which one. See, I'm just clicking on the run button. So it says 0s and 1, 0, 1. Okay, so it does not give you the guarantee of the order. Now you see thread 1 and 0 is running. Is it clear?
Sorry.
The execution order in the priority, when you're running with the priority, the execution order, okay, that is not guaranteed. Okay, that is not guaranteed. Okay, your CPU will decide. Okay, even though if you give the priority, the execution order is not guaranteed.
Yeah.
Okay, all right. And again, I'm sorry, I made a mistake of not creating the object for this particular class. Though I copy pasted and I went with that, so that is the thing. Sorry about it. Okay. So yes, this is with your yield and the priority. Okay, yield and the priority. Now the next method, which method you wanted? Yes.
Yeah, second to 1 and 1 to 10.
Which one? I'm not getting it.
There are two methods, na T2, sorry, two this T2 and T1 are there, na objects.
Yeah.
So we can, you already set it 1 and 10, na? You can set 1 or 2, 1 or 3, 1 or 5, anything
In
either.
1 second, I will add one more also, T3, and I will set the T3 set priority.
9 or 8
Okay.
or 7.
Okay, I'll give 4.
Yeah. It will execute 4 times. And
4 times 5. It's just a priority, right?
yeah. Can you just
Okay,
run?
so even in that case, we want get T2, T3, and T1 because for T1 we have the priority 1. Here we have the priority 4, right? That was the order. But you can see 1 is running, then 2, sorry, it starts with 0, right? So 1 is 10, 2 is 1, 0 is yeah 1. If I want, I will give like this, just a second. Get me. What happened? Oh, it says thread 0. Okay. I'll just say, so let's say get name. I'll put it like this for you. Okay. So get name, it's giving the thread 1, right? Okay. So now we can get it. Okay, so now you can see we have the thread 1 is 1 priority, so that is running first. 2 is 10, that is running last. 3 is 4, that is running the middle. Now if you keep on execute, so you can see the order is not, I mean, we cannot guarantee the order. The CPU will decide. Even though you set the priority, but the CPU will decide which to run. Clear? Is it clear? Clear? Are you there? Are you there? Are you there? Can you respond, please? Are you there? Pawan, can you respond? Are you there?
Hello? Yes, yes.
Okay. All right. So now coming over here, I hope you can hear me, right? Okay.
Yes, yes.
So now the next problem when we use the thread, if you see, when the multiple thread access the shared resources, the data inconsistency might occur. So when we are using a multiple thread, we will face this problem also. Okay, when the multiple threads access shared resources, okay, that time data inconsistency might occur. So for this, we will be calling like a thread synchronization. Okay, we will call this as thread synchronization. Just a second. So we call this as thread synchronization. Okay, so how we can resolve this? Now coming over here, let me create one class. Okay, I'm saying sync. Okay, so now coming over here, okay, what we are going to do is let's have one object, I mean, sorry, one class over here. Okay, so let's say like class, let's say order. Okay, and then I'm going to have class thread one that extends thread. Similarly, I'm going to take one more thread over here that extends. Okay, now coming over here, what I'm going to do is this class. Okay, this class is there, right? So I'm just going to have some methods over here. Okay. So in this class, I'm just going to have some method. Okay, so let's say what kind of a methods that we can give our own methods only. It is not that we have to stick to the default methods or anything. What you want, you can go ahead and you can create it. Okay, what you want, you can go ahead and create it. So for example, let me say, I'm just going to say synchronized void, and then let me order, then let's say n. It's a synchronized method over here. I equal to taking with 1 has to let's say like a 5, and then let's say I plus plus. So here I'm going to print the number. Okay, let's say n into I. So now let me use the try method. Thread dot sleep. I'm going to sleep it for 500 milliseconds. one of order object, because here we have a constructor, right? Here we have a constructor. Similarly, what I do, I will do for the thread too. Thread. So what, I'm sorry. So what this method is doing?
Hello. Hello. Hello.
Can you hear me?
Yes, yes. Tell me.
Okay. So here we are using a synchronized method. Okay. So now what is synchronized method? So synchronized method means it will ensure that only one thread at a time can execute. Okay. Only one thread at a time can execute, and that method on the same object. Now coming over here, I have one object only. Okay. I have one object. Okay. I have one object. I pass the same object to both the threads. So for if you see, whenever we run the thread, okay, whenever we run the thread, it will run at a time, right? It will run at a time. All the threads will start at a time. But now coming over here, I'm passing a class object to to both the threads, which means it will start at a time, right? T1 also will start at a time. T2 also will start at a time, right? But I want to ensure that only one thread that runs. Okay, only one thread at a time it want to run. So for that, we are using the synchronized. So this synchronized method will prevent the multiple threads from accessing the shared resources simultaneously. If I say order object, one object we created for the order class, and that object we are passing it through the thread, which means what happened? Both the threads will access this order class for the same object, right? Simultaneously, that too. So we wanted to avoid that. So that, I mean, in order to avoid that, we are using the synchronized method. Okay, we are using the synchronized method.
So how you are avoiding, where you are avoiding? Can you show
By
me?
using the synchronized method, it will be avoided.
No, you are using this particular word, but what logic inside this? Can you
Here,
explain?
okay. See, when you say synchronized, it will automatically ensure that both the threads are not executing at a time. It will execute one by one only. That is what the keyword synchronized means. If you want, we use the print statement here, right? If you want, I will do this for you over there. See, synchronized is a keyword you don't want to explicitly do. Okay? You
Print
don't want to
already there, na? Print
that
is
is, I'm just printing the number. I'm
yeah.
going to pass. See, here I'm saying 5, 10. So what will happen? 5 times it is, I mean, 5 times it is going to iterate. And if I say 5, it will say 5 into 1, 5 into 2. The table count.
Can you
That's it.
print? Can you print this? Hmm.
Now, if you wanted, see, it starts with, I'll give another number over here. Let me say this as 8. Okay, and I will give this as 15. Okay, so that now you can see first 8 will execute and then 15 will start. See,
Why it's 2 times? Why not 5 times? Because two objects are created.
okay, now coming over here. Okay, so once again, so let me see over here. 8 is started first, right? So 8 is started. One second, I'll just make sure this also is there so that it will be easy for you.
No, I understand because 5 times already there, na? 8 is to 5, 40. Then only two objects are there, O1 and I think thread 1 and thread 2 are there. So two threads are executing.
Overall 10 is there. Overall 10 is there. So now coming over here, okay. So if you want to, I mean, if you let's say like
In one thread, there are five, we can say five
it's a shared
processes.
resources, right? So
Yeah,
it's
yeah,
now coming
resources
over
are there.
here. Now we have a shared one. This order class is a shared resource for by both the threads, right? So what this class is doing, this class is having a method that is print order, which prints the multiplication table of this en 5 times. Okay. So now the synchronized keyword that will ensure that only one thread at a time can execute this method. Okay.
Okay.
All
What
right.
is deadlock? Deadlock?
I didn't use deadlock over here.
No, no.
See,
What?
you don't want to complicate it into multiple methods. Okay, if you take one topic, let's finish it off and then we will go ahead with the next one.
Yeah, yeah,
So
sure.
you don't want to confuse yourself. Okay. So
Okay.
now coming over here, synchronized. Okay, so this will ensure that, okay, only one thread that runs at a time. Okay, so now here we are using a thread sleep. So which means like we are making a pass over here for 500 milliseconds to simulate a delay. That's all. Okay, so now if I'm not using this delay, what will happen? At the time it is see, at the time it is printing, right? At the time it executed. You can see the order also. See, now if I say this sleep, there is some delay. There is some delay, right? Okay,
This
now
delay is, I
then
think, 500 milliseconds. Huh?
yeah, 500 milliseconds. If I say this 5000 milliseconds, you can see that will be like 5000 milliseconds. So you can see it is slowly coming up. So to avoid just 500 milliseconds. Okay. Now coming over here, we have two class thread 1 and thread 2. So both the threads share the same object. Okay. Both the thread share the same object, order object, and it is calling the print order, but with a different value 8 and 15. Okay. 8 and 15. So each thread stores a reference to the same order instance. So for example, if I wanted to say like again, if you say 5 and 10 over here, we have the number 5 and 10, which is a different value. Now this each thread 1, let it be, thread 2, let it be. This method that stores the reference to the same order table, order instance, right? So print order 5 is there. So coming over here with the 5. Okay. So now coming over here, if you say this order 1, here also we say order 1. Okay, which means like this both the threads that stores the same reference to the object, I mean the order instance. Now the run method will call the order print order where n is either 5 or 10. Okay, where n is either 5 or 10, because both are sharing the same or same instance it is using, right? Same instance it is using. So will be either 5 or 10. Now coming over here, okay, coming over here, if you see this, we are creating only one object, and that object is shared between two threads, and we are starting it. So overall, if you see, we have a single order table. I mean, here we have a single order class, okay, with the order object that is created. Two threads are started. Okay, two threads are started. Now, this print order is synchronized. So it will make sure that only one thread is executing in a time. It avoids the interleaved outputs. And now why we are getting this order? Okay, if you see, you will be getting the same different order as well. Now, why we are getting this order? Because print order is synchronized only one thread runs at a time. Either it can be a T1 or T2. Okay, T1 is for 5 and T2 for 10. Okay, so 5 times, 5 times. That is what we are printing. So less than 5, right? 5 and 10. So now if you give here the same number which we gave, 8 and 15 over here. So first 8 times will be for 5 and 15 times will be for the 5. So you can see 5 8s are 40, then 15. So 5. So totally you have 10 for the two things. So now what if we remove the synchronized? If I remove the synchronized, what will happen? Yes. What will happen if I remove this synchronized?
If you will remove the synchronized, then I think the process will not execute one by one. It will execute simultaneous. I don't know, some error might be there.
It might lead to an error.
Randomly. It's
It
not in
might
order,
lead to
it's
an error, and it
randomly.
is, see, first you can see 15. Okay, 15 is coming over here. And then you can see over here 8, 16, then 30, 24, 45. So if you want, let's
So
say
it means
here.
there is no order. It's just executing any of the process. It's
Yes.
like,
Oh, sorry, my bad. Can you see? So both the threads are executing simultaneously. If you want to avoid it, then you will be using the keyword called synchronized in order to avoid the simultaneous.
yeah,
First your 8 will execute, then 15 will be executed. Though we have given for the 5, so both will execute for the 5 times. Okay,
yeah.
all right. So now the next thing, if you see, you asked deadlock, right? Okay, now what is deadlock? When two or more threads are waiting for each other resources indefinitely, that will, deadlock will occur, which means when no thread can proceed. Okay, when no thread can proceed, that causes the program to hang. Okay, so a deadlock will occur when two or more threads are waiting for each other resources indefinitely. Indefinite run will be there, right? So which means like no thread can proceed. So that will cause the program to hang. Now let's say, okay, let's understand this deadlock with an program. Deadlock tester. Wait. I'm not giving. Okay, I think I'm making a mistake over here. One second. Oh my god. This has to move to here. And my deadlock has to move to over here. This one. So what are the concepts that we have seen? Thread tester, priority, yield. After that we have sync, and then now deadlock, right? Yes. All right. Now it is in order. Okay. So now the deadlock. So now let's say like I will create one class over here. Let's say like a shared resources only. So now let me say like static final object resource 1 equal to new object. I'll write and then I'll explain you what is doing. Then I'm going to have a class thread 1 extends thread. And let me give the run method over here. Public void run. Okay, so and then coming over here, I'm going to have 2 threads. Because for the sync also we used 2 threads, so I'm just going to use the same 2 threads. And then in the deadlock one, I will make use of thread. Okay, so I'm just going to create a thread 1. Okay, so this will be thread 2. So I'm just going to say thread 1 equal to new thread 1. I'm just creating an object over here to start. Two, two, and then two. So I'm going to say one dot start T2 start. Okay, now coming over here, we have to write the run method. Okay, we have to write the run method. So inside the run, what are the steps that we can give? Okay, let me use the synchronized over here. Sources dot resource 1. Then I would say system dot hello thread 1 locked resource 1. Try thread not sleep. Let me say this time I will give a child interrupted exception. Okay, it's already defined. Okay. Let me say T1, T2, say T1. So now what we are doing over here. Okay, so in this method, what we are doing. Okay, so here we are, we are going to understand about the deadlock situation. What is the deadlock situation? So we have 2 threads over here, thread 1 and thread 2. And they are getting stuck waiting for each other resources. Why they are getting stuck? See, thread 1 and thread 2, they will start execute. When they start executing, thread 2 is locking the resource 2 and thread 1 is locking the resource 1 in the beginning. And after that, your thread 1 wants the resource 2 to get execute, and your thread 2 wants execute the resource 1. But both the things are get locked already. Okay, it got locked. Okay, so that is what the deadlock over here. Okay, now let's say like you are playing cards. Let's imagine. Okay, you are playing cards. If you get let's say like if you get a king card, you will win. But the opponent is holding the particular king card. That is what the deadlock over there. Clear? Okay. Now, coming over here. So what I'm using over here is I have one class in the name of shared resources where I have resource 1 and resource 2. Okay. So this shared class that contains two shared objects, that is resource 1 and resource 2. So that both the threads that can access this. So why I'm saying final, it cannot change anything. I'm just giving the data type as object. Okay. Now, we have this class. Okay. Now, coming to the thread 1 class, what we are doing in the thread 1, we are using synchronized, which means like the resources will access one by one, not simultaneously. Now, your thread 1 that locks the resource 1 first, and it is sleeping for 100 milliseconds. And it is then trying to lock the resource 2. Okay. Resource 1, 100 milliseconds sleep, then resource 2. Now coming to the thread 2, it is locking the resource 2 first, and then sleeping for 100 milliseconds, and then it is trying to lock the resource 1. Okay, but when it is trying to lock the resource 1 as a second step, your thread 1 has already locked the resource 1 in the step 1. So for example, let me make it clear here. T1 is here, T2 is here. Okay, so now we have two objects, that is resource 1 and resource 2. Here we are given the synchronized one. Okay, so synchronized one. So when you say synchronized, okay, both the resources will not access at a time in the thread. It will access one by one. So now your first thread 1 and thread 2, they will execute simultaneously. So your thread 1 has taken resource 1 and it is locked. Okay, it is locked. Similarly, thread 2 that has taken resource 2 as the first step and it is locked. Now, once that is done, they are waiting for 100 milliseconds. Then your thread 1 is trying to lock the resource 2. But this resource 2 is already occupied in the thread 2. It is not released yet. Until it is not released, it cannot be used by any other threads. And that is what the deadlock over here. Which means your thread 1 is waiting for the resource 2, which has been locked by thread 2. Your thread 2 is waiting for the resource 1, which has been locked by the thread 1. Until they release this, your next step will not get executed. And that is the reason the deadlock occurs over here. Thread 1 locks resource 1 and it is waiting for the resource 2, which is being locked already by the thread 2. Your thread 2 locks the resource 2 and waiting for the resource 1, which has been locked already by the thread 1. So both the threads are waiting for each other indefinitely. There is no time at all. They are keep on waiting. And that is what the deadlock. Is it clear? Now, if we execute this, see, thread 1 locked the resource 1, thread 2 locked the resource 2, still your program is running. It's still your program is running. You can see here, right? It is keep on waiting. So you can see these messages, and after that, the threads are waiting until we hung up. It will keep on waiting. Now, how to prevent this deadlock? How to prevent this deadlock?
Try lock, I think we can use method try lock or that by
Okay, we can
using
use try lock also. Yes, we can use it. Any other one?
how to prevent, you mean, or how to implement?
How to avoid blocking? How you can prevent the deadlock? Either you can use a consistent locking order. So to avoid the circular dependency, you can ensure that both the threads lock the resources in the same order. Same order means here also resource 1 and resource 2. Here also resource 1 and resource 2. Like that. In the same order. If they lock in the same order, there won't be any deadlock. Okay? There won't be any deadlock. Okay? Waiting for, okay? There won't be any deadlock.
Can you
Oh,
repeat
sorry.
again, please?
Wait. 1 second. 1 second. Now, here, first resource 1 is executing, then resource 2 is executing, right?
Hmm.
In the thread 2, resource 2 is executing, resource 1 is executing. So, which means like in the thread 1, first one is resource 1 and next one is resource 2. In the thread 2, resource 2 is first and resource 1 is next. So, instead of giving in the circular 1, go with the same order, R1 and R2 in the thread 1 and R1 and R2 in the thread 2. In the same order, instead of giving in the different orders, give the same order. That will also avoid the deadlock. So now let's see. So in the thread 2, I'm just changing. So instead of getting the resource 2, I'm just getting a resource 1. And in the place of getting resource 1, I'm getting resource 2. So when you give like this, there won't be any deadlock. So you can see both the things. See, thread 2 locked resource 1, locked resource 2. Thread 1 locked resource 1 and locked resource 2. Right? So you can go ahead in the same order. That is what the consistent locking order we will say. To avoid the circular dependency, we can ensure that the threads, both the threads, they lock the resources in the same order. Okay, this we can do. Or the another one. Okay,
So you mean
the
with
another
the help
method.
of consistent orders, we can improve this.
Yeah. Okay. So that will ensure that no thread waits indefinitely for the resource that is being held by the another thread. Right? If you go in the same order. If not, you can use try lock. Okay. Instead of using the synchronized, you can use the try lock. Okay, you can use try lock. So instead of using the synchronized, you can use the try lock. So I will create another method for that. Okay. Now again coming over here, I need the same thing. So let me copy and paste it over here. And then let me say like L1, L1, and let me say L1, L1. Okay, and coming over here, I wanted this particular steps also. Okay, now let me say this shared resource I want. And coming over here, let me say class thread L1 extends thread, and I wanted L2. So now instead of using the synchronized, we are using the try lock. How we are going to do? So now let's say like share the resource. What happened? It's already declared. Let me say share the resource 1. Now let's say like public void run. Now I'm saying while true, if my shared resource 1 dot lock. Okay, so I'm just going to say lock 1, or let's say like Let me make this to lock. I use the dependent lock to, and this one I will change it to new re-entrant lock. I will use this. Okay, so now coming over here, let me say lock one dot try lock.
What is retrent lock?
Okay, so re-entrant lock. Okay, so coming over here, you can see over here that comes from the default package, that is like concurrent locks. So what it's
Okay.
doing over here is it provides the alternative of your synchronized method. So this re-entrant lock is the alternative method of your synchronized.
Okay.
Okay, it allows the, like, let's say like explicit control. When you say synchronized, implicitly it controls it. Oh, you don't want to use the synchronized, right? So you want to use try lock. So which means like you want to explicitly control over the locking and unlocking the resources, right? So for that you can use this re-entrant lock. Okay. Now, yeah, coming over here, let's say like try. I'm using the same thing. Let me say. So we are using finally block to unlock it. Okay. We are using the finally block to unlock the resources. Now, similarly, the same thing. Okay, so you can see over here, let me take the same thing. The order will be lock 2. It is locking the resource 2. If the lock 1 try lock 1, thread 2, thread 2. And finally, you are going to unlock. See, same process only. In the synchronized, in the deadlock, if you see, by using the synchronized, we said our resource 1 first and resource 2 next for the thread 1. And for the resource thread 2, resource 2 and resource 1 first, resource 2 first and resource 1 next, right? Same order only, but here we are taking the control of locking and unlocking by using this try lock method. Okay, by using this try lock method. So you can see we are keep on executing. If it is true, we are just going at. So here you can see the shared resource is the class. So lock one is the object that we have, and try lock. Okay, try lock. And now it is coming over here and it is saying it will print thread one. It is locked the resource one. Now the next one, it says whether the lock two is try lock. If it is there, lock the resource two. If once the resources are blocked, just come out of the while loop. So once we are coming out of it, what will happen? Finally, the lock 2 will be unlocked and lock 1 also will be unlocked. Same steps that we are using in the thread 2 as well. Okay. Now, let's see the output. Can you see? It keep on executing. So if the thread cannot occur the second lock, it releases the first lock and it will try again. Okay. If the thread that does not take the second lock, it will release the first lock and it will keep on trying. Okay. So this avoids the waiting forever and it will prevent the deadlock. So deadlock
Can
will
you
happen. Yeah.
explain one block again that you explained before in that class 3 del 1?
Which one? This particular one you are saying.
Yeah. While
Okay. All right. So now coming over here, we are using the re-entrant lock and the try lock. Okay. So why we are using these two locks, which means like to prevent the deadlock. Okay. To prevent the deadlock, we are using this. So your traditional deadlock, if you see, your traditional deadlock means you have to wait for, the thread has to wait indefinitely because there is no time limit at all. It has to keep on waiting until it gets the resources. Okay, now coming over here, how you can avoid it? First, the same thing, we are having the shared resource. It's a common class. Okay, it's a common class. So this class contains two locks, lock 1 and lock 2. Okay, lock 1 and lock 2. And we are using a re-entrant lock, which allows us to explicitly control the locking and unlocking. Okay, then coming over here with the thread class 1. Okay, in the thread class 1, how it works? First, we are trying to lock our lock 1. Okay, first we are trying to lock our lock 1. If it is successful, okay, if it is successful, then we are going to try the lock 2. If lock 2 also happened, then we are stopping the process. Okay, suppose if the lock 2 is not locked by thread 1, then we are releasing the lock 2. If the lock 2 is not available, sorry, if the lock 2 is not locked, we are releasing the lock 1 and we are trying it again. That is the reason we are going with a while loop. I repeat, we want this thread 1 that wants to lock.
See, I not understand the. See, you have written this 70 line. If shared resource 1 dot lock 2 dot try dot lock, then try this break, then finally again
Okay.
lock 2 dot unlock. I think here lock 1 should be there, eh? Lock 1 should
No.
dot
See, let
unlock.
me tell you. Let me explain you. Here, I'm using the while loop, which keep on execute until I say false.
Yeah.
Now, I have two resources, that is lock 1 and lock 2. Okay. Now, I am checking whether I can lock 1 or not. If I can lock my lock 1, I am going inside and I'm trying to lock 2. If I can't lock this lock 2 means what I am doing is I am coming out, I am releasing the lock 1 and again I am trying to lock both. So this process keeps on execute until I lock my lock 2 also. You got it? So that is what the shared resource 1, lock 1, try lock. Try lock means I'm trying to lock. If it is yes, I'm going inside and I'm printing thread 1, locked resource 1. Then once I'm logged it, I'm trying to lock my lock 2. I'm trying to lock my lock 2. If that is not happening, so which means out of my if loop, right? So I'm coming finally and I'm unlocking my lock 1. Then again while loop, it will come. It will try to execute. It will try to lock 1 and it will try to lock 2. If it is done, yes, I'm breaking. I'm coming out of the while loop because both the lock I have done. You got it? So if you come over here, you see the execution. Thread 1 is locking the resource 1. After that, not possible for the lock 2. If you want, I will print and show you. Yes. Not possible to lock 2. Hence, releasing the lock 1 and trying again. The same else part I will put it for the thread 2 also. So that will make something. So here not possible to lock the lock 1, hence releasing the lock 2 and trying again. Now see. Can you see thread 1? It is locked the resource 1 and it is trying to lock the lock 2. So not possible to lock the lock 2, hence releasing the lock 1 and trying again. So thread 1, again it trying, again trying, again trying. So you can see thread 1 is keep on trying, right? It's thread 1 is keep on trying. Now finally, like let's say like when thread 1 is locked the resource 1, now the similarly thread 2 also trying it. Okay?
Yeah,
Trying
I
it.
understand. Once the thread 1 is locked, then till the time thread 2 is locked, it is trying thread 1 only. So it's printing
It's
thread 1.
coming over. You
Once
see,
thread 2,
when
yeah,
both the threads are locked, both the resources, my program got stopped. See, well, let's say like I have 2
yeah,
locks. Okay, and you are also having 2 locks. Okay, so there is a game. Okay, we want to execute, we want to lock both, we have to unlock both the locks or we have to hold both the locks. Okay, there will be a key, right? So the 2 keys will be with you and 2 keys will be with me. But the 4 keys which we have totally, it's like shuffled. So until I unlock lock 1, so there will be like, so try from the first. If it is not, I mean, at the end, the moment, if it is not unlocking, you have to start from the first only. Right? You got the point? So you have,
so
let's
this
say,
deadlock is mainly for locking the threads, both threads in any. I mean, whether it's randomly or anything. If we want not to show any something in the program or something in the process, we can use this this deadlock or try lock. I think, if I'm not wrong.
see, using the dry lock, so using the deadlock, if you see, if you want to occupy something, okay, if you want to occupy something which you don't want to release it, then you can go ahead with a deadlock. Okay, but when you're having a deadlock, none of the threads will proceed. Okay, none of the threads will proceed. So which means like you have to terminate it manually. So to
Yeah,
avoid this
that is what I'm
deadlock,
saying. If you, if we want not to show anything, let's suppose we have program for some interface, we have some banking application or anything. If we want not to show something to the user, we can simply deadlock that process in the program. That's it.
you can
If I'm
deadlock
not
it.
wrong, I don't know.
Yeah, you
If,
can deadlock it. So if you don't want to continue, you can use the deadlock. But at the
yeah.
same time, when you are using the deadlock, it will
Uh,
cause the program to hang, which means like it will be keep on waiting also
yeah,
until
understand.
it
It
gets.
will
So
occupy
which
the resources and it will hang the
will be
program.
hang now. Okay. So you don't want to continue. So that is what. So that is what in the cards game, if you see, you are a group of 4 playing it. It will be like a round robin. Each person will take a chance. Now you know that your opponent will win if you release one card. That card is king card. If you release the king card, the next person,
Hmm.
the person who is sitting next to you will win. So what you're doing, you're locking his victory by keeping the king. So the chance will keep
Hmm.
on executing only. But that opponent, he's having no chance of playing also. He wants only the king card. So what will happen? He has to keep on waiting, right? So you are
Hmm.
using a deadlock that is letting the opponent to wait, right? So that is what the program to hang. He is hanging, right? He's hanging for victory. So if you release that, yes, he will win. If you're not releasing it, he has to wait. That wait will be happen over here. Got it?
Hmm. So, and what about the trilog and to
Try
remove the
lock is
hanging?
like you are manually controlling it. Deadlock is like internally it is taking care. Okay,
Hmm.
now your try lock is like a drill master, you can say. Okay, so now you have locked this. Okay, you unlock that. I will lock it over here. So like that. Okay, so they will be like, okay, they will say like, so your opponent needs 2 cards. So one card is with you, another one is with your friend. So you have the mutual understanding. Okay, now I will release the king card. You keep that card. So that next time he will give me the king card, he will rotate the king card. So I will keep that. So like that it will be coming. That is your trilog, which means like you're going to explicitly control the lock with the trilog. Deadlock is internally it will be occupying it. You got the point?
Yeah.
Okay. So yes, so that's it with this multi-threading. Okay. So I'll share these files on the chat. You can try to take it out. Okay. So
Can you also show me the link?
I'll show you now. Just a second. And let me open my browser. So meanwhile, you download these files. I will open my browser to the hacker rank. Let me check. Yeah, here you go. I'll share the screen. I'll just show this and then just see now coming over here. If you go to this particular link, okay, hacker rank. Okay, so as I said, this hacker rank, it's like a skills tested. Okay, so you have this certificate like skill verification. So if you have for multiple languages. Okay, so now if you search for Java, you can see here. So Java basic is there. So which means like it covers the basic topics like data structures, inheritance, exception handling. So whatever we have, right? So just you can go ahead and you can take this. Okay, take the test. Suppose when you are saying like, let's say like, let's say like you are taking this, you have to continue. So I have this account. So you can either use your Google account, GitHub, or your LinkedIn to start with. Okay, so it will take some time. Let me see. Okay, I'll say my Google. I'm using my Google account to signing in. So now you can see it will come like this. Okay, so you can go ahead and start it. You can say get certified. Okay, you can give your first name, last name, and then you can start
No, that's
your
fine. Login I will do. Then after that, can
that
you
is what,
just
wait
log in?
one second. When you say start test, it will start. Suppose once you give a start, right, it will be asking you. So you will get a certificate like this.
Okay.
So you can show it in your LinkedIn profile also.
Oh, that's fine. But before starting this,
Now,
let's
once
suppose.
you say start, once again, once you say start, it will take you to the page, okay, where you can have your practice test. Before you do the confirmation, it will be asking you to say practice test. So you will be getting a practice test environment where you can practice for the practice questions. After that, you can come and you can start your actual test.
Okay, so practice test also there. Then after that,
Practice also there. You can, before you say continue, even though if you say get start test, okay, it will be asking you like whether you want to go ahead with the practice. See, try sample test. So if you go ahead with the try
That's
sample,
fine. So for the sample, you mean for the sample questions, I can try from here. Any other site is there to try for the sample questions?
uh, okay, for apart from this, you have lead code. We have, I think, lead code. Lead code also you have. Now coming over here, you have your problems. Okay, just you have your problems, whatever you want. You have your problems like here with a state like easy, hard, medium category. Okay, so you can go ahead with this also.
Okay.
Okay, so if you get, if you do at least one question, so two questions will be there. If you at least do one question, it depends upon the test cases that you pass. Okay, you will get a certificate, and that certificate, yes, you can put it on your resume, and also you can put it on the LinkedIn profile. That is what.
Okay.
Okay.
Yeah.
All right. So that's it. So thank you so much. Try doing this hacker rank and the lead code. Okay. So maximize your.
Sure, sure.
Thank you so much. We'll connect back tomorrow then.
Thank you. Thank you.
Thank you.
Tomorrow, which
Bye.
topic will you discuss?
Which one?
Which topic you will discuss tomorrow?
I just look into the syllabus and then I'll get back to you. I'll just update it. Okay.
Okay, you please
Yeah,
drop message in the group. Yeah,
sure.
thanks.
Okay. Thank you.
Thank you.
Bye.
Okay, bye.